anyway, thank you for joining us for Percona University. I wanted to make sure to say thanks to a number of people and companies who help us to make it happen. We're very happy we could latch on this fourth Asia event taking place here, and provides more content to folks who are interested in open source database, this in particular. With that, I also wanted to cover few things, right? But I have a lot of people asking me about the from Percona University events in particular. First one is some people say, hey guys, you are talking a lot of things about Percona, and what if you want to do business with Percona, right? I am actually not the best person to talk about, right, how all those things work, right, that we have this fantastic salesperson, right, who is responsible for your region, right. If you guys want to contact him directly, you can do that. The second question is I often hear is some people attending those events from somewhere afar and, hey guys, what would it take to get Percona University done in your city? And we really like to do those in the places where we have some support from local community, right? So if there is somebody, would like to bring that in some other country, then yeah, give us feedback, and we would happy to do that. And the last question is what I often get is, are you guys hiring at Percona? And yes, we do, but I am not really tracking what positions are open. I'm not the best person to look into that. Here is the QR code and some of the positions that we are hiring. With that, all the administrative stuff out of the way, we can now talk about their open source databases, right? I think that is sort of a big part where a lot of talks on Percona University events will be centered around that. And I wanted to talk about kind of two sides of the open source databases. One is what happens in terms of important innovation in the field. And then the second one will be kind of more in terms of what happens with open source side of an open source database, which I think is also very important. So let's talk about what happens in their database from innovation standpoint. One thing, and I think, is their distributed databases, right? When I was starting with database technologies, if you think about Postgres, MySQL, many other databases, they're kind of really built to be first and foremost as a single node databases operating on a single server, and then they have been adding some features, right, to get more distributed. If you look at a lot of databases which are kind of being built recently, right, these are distributed databases because if you want to support very large applications, right, then that is often very distributed databases which are needed. And that is also very typically you can hit some other needs as well, right? For example, for high availability, right, when you need your data to be distributed in different regions and so on and so forth, right? Example of, Cockroach DB, though not exactly open source, right? TiDB, Yugabyte, right? Now we also have a representative here from wonderful database called YDB, right? You guys may heard about that or about this from South Asia. Another interesting trend what we see, and that kind of comes to us from the analytical databases, but we can see that more in their operational database as well, is separation of storage and compute. Where we can say, hey guys, you know what, we don't want just to look at that of a server where compute and storage, right, are packed in the nodes, and then we scale that by adding more nodes. We want to store storage and compute separately, because there are some databases which may be relatively small, but they need a lot of processing, right, related to it. Or sometimes you have a database kind of very, very large, right, a portion of that, right, but you don't need to have a lot of query processing, and kind of getting that together is not very efficient, right? So that is where we see some interesting trends coming up as a trend, right? Like, for example, in a PostgreSQL space, some of you may have heard there is a project called Neon, which is, using a lot of the approach where a lot of database can be stored on the S3 compatible storage, right? And there is a lot of work in a database, especially which is designed from ground up, which is using this pattern. The next approach, at least as an option, is the serverless, right? And the serverless, especially when you think about database, is kind of misnomer, right? Of course, there are going to be somewhere servers which are going to run your queries, right? We did not figure out how to, just run the queries in a thin air, right? But the idea of a serverless is what, instead of thinking about the concept of how many servers I deploy, right, you just say, hey, there's going to be some database that's going to provide you kind of endpoint, and you control that through a scale you require. You say, hey, I need more performance at more cost, or maybe less performance, instead of thinking about the servers, right? And the database itself, or maybe a cloud vendor, right, they manage the capacity that's needed. Again, a lot of that comes from the analytical databases, like Google BigQuery, right, for example. But we are seeing that coming in operational databases. And the other side, when it becomes very important, is actually very, very small scale. For example, a lot of applications are being so-called vibe coded with AI right now, right? They often would need some sort of database, but that database may only have a very few requests, right? You just got a few requests, and then it's kind of down for a few hours, and then you send the link to a friend to check out, and we have 5 more queries, right? Having the node kind of spinning somewhere using CPU, memory, doing nothing is very inefficient, right? What we rather have in this case is sort of like a multi-tenant serverless database, right, which serves very, very large number of customers, right? And if customer doesn't create any load, right, then the cost of maintaining the database for that customer is very low. Then there is a concept of hybrid and transactional analytics database, right? That is the idea, is what you want to have a database which kind of can serve both transactional and analytical traffic at the same time, which kind of plays together, or sort of with another trend, which is kind of almost the opposite, right? Which says, well, while in some cases you would want to have a database which can handle it all, right, at least to a certain scale. Think, like, for example, Amazon Aurora can handle analytical queries better than, just plain Postgres, right? Or MySQL has a heat wave, right, in the cloud to optimize such queries. The other approach would be, well, you know what, actually we want to move the data and store that several times and use appropriate engines for different kind of use cases. For example, you may have Postgres as your transactional database, where you have some, let me call it kind of data pipe, which pipes the data in something like ClickHouse, where you can process that for analytical workloads, right? And maybe it's only kind of also goes to something like data gets archived to S3 compatible storage, and that is where we will use to train our AI models for, something like that. Next, we have a concept of their multiple databases, right? When I was, let's say, like early on in my career, you often would have like one database. You just run MySQL and kind of that's it. And frankly, in late 90s, early 2000s, there was not as many open source databases to choose from. Now there is a lot of them, right? And often you have a single organization which may run very large number of databases, especially for large organization, right? I would remember I asked guys at Facebook, what open source database guys do run? They say, well, all of them, right? Because that is The big organizations, there is a lot of teams with a lot of authority, right? They like to experiment, so they try to, pretty much everything. And those different open source databases now, again, comes with a different data models. It's not just about relational anymore, right? We have a time series databases, graph databases, data structures, document databases, and their databases focused on the vector search, and so on and so forth. Many of them also can now come as supporting multiple data models and even talk multiple protocols. For example, Postgres, of course, is a relational database, but it can also store JSON pretty well, right? Or has added support for storing vectors, right? Which is, kind of different data structure. Or I mentioned ClickHouse here already, right? ClickHouse is a database, analytical database, which has support for its native ClickHouse protocol, but it also has support for MySQL and PostgreSQL protocols as well. Now, of course, as if everything in technology, the big trend impacting the databases is AI, right? And I think AI touches the database from very, very many different angles, right? And I don't have a time to, go exactly in all of those. That would require the separate presentation or presentations, but I wanted to mention few. One is vector search, right? Anybody heard that term as it relates to databases? Okay. And this is the technology which supports building a lot of applications which use AI, right? Now, if you think about that, okay, why vector search, right? It's kind of confusing. We talk about AI, LLMs, right? And there is a, vector search. What is relationship? Well, and if you think about that, right? If you go deep down to a lot of those AI algorithms, right? They're not working with your images, or sounds or words inside. Inside, all of those objects, right, are converted to some sort of vectors. And underneath those wonderful AI model, there is a shitload of vector math, right? If you look at that. When we talk about the real-world objects, right, how they are represented for processing, they are represented as vectors, right, like a long-dimensional vectors, which are also often called embeddings. And the vector search functionality, it allows us to work with those embeddings efficiently, where traditional databases, they have not been successful with. Now, the second item what I would mention to AI is the concept of a self-driving databases. I mean, you guys, of course, know AI companies, they want for all of us to use our jobs, right? That is their mission, right? You can, go and read OpenAI mission, and they say we want to ensure that no software engineers have his jobs anymore. That's a joke, by the way. I'm just checking if you listen to me. But in reality, there is a lot of push how we can automate things. So instead of DBaaS manually working with databases, we can get database as much as possible to manage itself, right? And that was happening kind of even before a recent sort of modern AI, right? I would say, which was happening for the last 2 years. The Oracle Autonomous Database, right, which is kind of similar term to self-driving, was introduced in 2017, right, almost 10 years ago. I think what is very interesting in this case is to compare the self-driving databases with the self-driving cars and think about the levels where we are right now. Now, if you think about the databases, if you look at the best automation which exists in the industry, right? Maybe even in some advanced clouds. This is kind of probably level 2, level 3, right? We are nowhere in that kind of full automation automation yet. I think what is also very interesting with databases, because they're so mission critical, so sensitive, right? If you fuck up your database, you may not have a business there. What a lot of people are quite conservative, right? Wherever you would want to trust the database or not. This is something I did a poll on LinkedIn about wherever, as of state of a database self-driving technology, would you trust it today? And well, you can see vast majority people say no. Okay, with that, let us move on and talk about the open source side of things. Now, what do you think is a factor which is impacting the open source right now, and actually was impacting for the last number of years already? Any thoughts?
Like AI.
Huh? AI. Yes, AI it is, right? But I think from a business standpoint, right, in this case. Well, license changes, I think, is a consequences, right? Of what? Of the cloud. There a lot of open source software kind of was built if creators kind of figure out different approaches for licenses, right? They may say, hey, we offer it as an open source, but we are going to get consulting or support revenue, right? Or maybe we'll use a dual license approach, right? So we would be able to sell software to the companies who cannot use open source license. And then with advent of a cloud, it kind of changed all of that, right? Because now hyperscale cloud vendors also often shrink wrap open source, right, and make it very easily accessible to their customers. I think the impact of a cloud is kind of interesting, right? Because on one extent, for a lot of open source software, it really maximizes and simplifies adoption, right? Think about Postgres, for example, right? Postgres was awesome database which was extremely hard to use for years, right? And then Heroku and a bunch of cloud came, made it easy to use. Now we have an advent of solutions built on the top of Postgres, such as Supabase, right? Which makes Postgres even kind of more usable for building applications, especially if you are using the cloud. But that also changes opportunity for monetization. Well, basically, who gets the money, right? Like, for example, if you look at their MySQL, well, before the cloud, it's MySQL, and then later Oracle would get the largest chunk of the revenue, right? And then they, of course, also will want to spend most of money on building MySQL. But with the cloud, Amazon probably makes a lot more money on MySQL than Oracle, just because their cloud business is substantially larger, right? Even though they are not developing a lot of MySQL, that is kind of still Oracle's job. I would say there is what it's good to remember when you talk about the open source, what the open source itself is not a business model, right? Open source can support multiple business model or require none. You can have your hobby to write and or support some open source project. Many smaller projects are exactly maintained by one or several volunteers, right? And they don't have any business model attached to them, right? But I think what you'll find is the cloud has been very disruptive to some open source business model. And I think especially that has been dependent on the ownership and the governance, right, of the open source, which you can roughly put in two different buckets. There is an open source, which is multi-vendor, right, or foundation-driven open source. Well, example would be Postgres or Linux, Kubernetes, right? And then there are single vendor-driven. Then there is like a one vendor which owns the software. You think about, MongoDB, Redis, Elasticsearch, MySQL, and so on and so forth. Now, if you think about the foundation-driven open source, right, because there's a multiple vendors impact, they really often love always kind of a cloud vibe, because that helps community. The software becomes more broad. It just changes who are those vendors. So if you look at the Postgres I mentioned, it was what the Enterprise DB was, this kind of the biggest enterprise company in the space. They would employ a lot of contributors, support the ecosystem very well. Now that has been shifted, right? You can see guys like Amazon, Microsoft, right? They employ a lot of PostgreSQL engineers, which work on the core Postgres, in addition to people who are improving their own internal PostgreSQL forks, right? And so you can see in this case how money flow kind of goes in a Postgres. It changed, but at the same time the community is very helpful, right? But then if you look about a single vendor, it becomes different, right? If you think about somebody like Oracle or MongoDB, right? They do not particularly care what the grass is greener, what MongoDB users are happier, right? Or MySQL for that stuff, right? This is commercial company, typically public company, and first and foremost, they care about how much money we make of that product. So then somebody else like AWS comes in and say, well, you know what, guys, thank you. Now we are going to make more money on this project and you're going to make less. They are not going to be very happy about that. And in fact, you can see what a lot of companies have been fully or partly kind of abandoning open source license, introducing some, different like source available licenses. It's also have been very interesting. Some of them would introduce those licenses, don't like consequences, and then sort of go back, right? Like Elastic and Redis, over the last couple of years, kind of went back with open source license, but I think still a lot of trust have been lost, right? In this case, I think what is very interesting in this case is what happens when you do so. And I think this is a very interesting picture which shows us the Elastic and the OpenSearch, right? You can see when Elastic get all those kind of open source license shenanigans, the OpenSearch appeared, right? And you can see it was kind of growing while Elastic was gradually reducing popularity compared to the DB engines ranking. What you can also note, though, in this kind of cause and effect scenario is what, by the time Elastic went and tried to change the license, they already kind of flatlined. And I think that is also an interesting in what happens, right? If a project is going kind of, ballistic, 10x in every year, right, or so something like that, then the companies typically have enough customer demand, enough growth, what they don't need to change the license, right, and use this kind of very tough policies, right? But when the growth slows, that is where license changes often happen. Like here's another example of MongoDB versus Postgres, right? Where you can see where MongoDB changed the license, right, and it kind of have been in a slowly decline by this, again, by the DB engines measure, where PostgreSQL, which at some point was actually even, you can see for a few years somewhere in the mid 2010s, less popular than Postgres, right? Less popular than MongoDB, I mean, right? Has been at significant upswing. And by the way, this graph is log based, right? So actual difference between those graphs as of right now is much more. And here is Redis. Wildkeys kind of, which is a Redis fork, is too new to show on this graph, but we can also see well, all those kind of license shenanigans in Redis ecosystems happened after it was past its peak, again, by this measure. Now, what was interesting with Redis in particular is when they change the license, their Linux Foundation, which is a very big player in an open source, has took an action. It did that very quickly, much faster than with any other projects before, when they kind of often wanted to stay away. And I think what was also very, very cool in terms of Valky Redis for creation is how many people got engaged, right? Or how many companies got engaged, right? We can see, guys, Google, AWS, and Oracle, right? These are pretty bitter competitors, right? But then they're all working together on Redis, right? And then we also have like a Huawei involved, right, from China, right, which is often kind of a little bit, different universe, right? And we are obviously very happy to be named also as one of the companies in this space, but of course, our contribution is much smaller. Now let's also talk about the MySQL, right, and a state of it. Now, the challenge, of course, with MySQL is what MySQL owned by Oracle, which is a very big public company. But I think the challenge for MySQL is actually more than what Redis or MongoDB, right, or Elastic has. They, of course, are also owned by the company, but that company is focused on the success of that company alone, right? Where MySQL and Oracle is kind of very small part of our business. So they are really can be a victim, and have been a victim, as we understand, of internal corporate politics, right? So then Oracle decided, hey guys, the only thing which matters right now is AI. So right, let us drastically slash over teams which are not AI related. The MySQL is a victim of that, even if the MySQL itself, right, may not be doing that well. So over the last few years, we see what Oracle has been reducing invested in MySQL. In particular, I think this one is very interesting, right? They had a very severe engineering layoffs in the last quarter, right? And we already can see that by number of contributors, right? We can see some other measures like number of bugs they say they fix in MySQL has been reduced. Now, well, we've been making a lot of noise about that recently, and not just us at Percona. It's nice to see what the MySQL community was doing that. So actually, Oracle have recently came out, and they are, promising to do better, right? You can actually see, even in addition to that letter, I think, they published some more some more thoughts, right, about what they are going to do with MySQL, right? There seems to be change in management, change in attitude, but we are yet to see what is going to happen, right? And wherever situation will change significantly. One thing I would also highlight is what, as I pull at least, my network on LinkedIn, right? There is not as much or trust to Oracle to actually follow through with those changes. Now, what would be a way, in my opinion, to improve the odds of that happening? And that is, I think, is what we need to make sure we have an independent community of all the MySQL players, right, which can keep Oracle accountable. And also, if things go very bad, it can exercise that fundamental right to fork, which exists in any open source ecosystem, right? So we have this, open letter, which, number of folks have came about, including Percona, right? And so if that's something of appeals to you, I would encourage you maybe to sign and help us to spread the word. Okay. So, going with that, I wanted also to mention something, right? I mentioned companies like Redis, Elastic, MongoDB, which went ahead and changed the license for their software. That's not what has been happening with Oracle. So far, we have not really changed the license. MySQL remains GPL, but that MySQL project was kind of neglected, with them having a lot of focus those days on the cloud version called HeatWave, right, as well as MySQL Enterprise Edition, which is not open source. But if you go back to the other players, which did change the license, now why do they do that? Right? What is really the point? And the point generally is creating monopoly in the cloud space, because that is the most important market for databases in those days. Like, why is that important? Database as a service, right? Or fully managed databases, which is another name. Well, because that is what gives us a state-of-art simplicity, right? It really somewhere where a high level of automation is possible, because all the cloud resources, they tend to be programmable, right? You can do self-healing, you can do scale, you can do all kind of other things, right? And what that allows is their developers to spend most of their time focused on, well, what developers probably should be focused on, right? By building applications, right, instead of wrangling with databases, right? And I think for a lot of application developers, right, we just they would see the databases as a necessary evil, right? It's not like, oh my gosh, I like to spend my all days figuring out while, some queries are running slow, right, and all this other kind of stuff, which, is fun for some database people, but not so fun for application engineers. Now, what do you think in this case is the problem, in my opinion, with a monopoly on the database as a service? Well, I think the problem is what this makes it really no different from proprietary software, right? Because reality is, for a lot of developers, that is the only level of experience they have to use a database, right? If you think about, let's say, oh, I have my own, let's say, hardware, right, or own VMs, and I am going to roll out the highly available Postgres out there with, Patroni, PG Bouncer. I'm going to set up all the backups. That is a lot of work, and that requires a lot of skill, compared to saying, hey, I just, spin up RDS instance, right? And a lot of modern developers, they just don't have that skill. The only thing they can do is to spin up an instance of a database, right? So that's stuff of self-hosting is not really feasible for them. Now, if you look at that, then that comes with a database vendor lock-in, or at least kind of vendor lock-in risk, right? And the problem, of course, with a vendor lock-in is if you don't have a choice, well, then you can have some pricing, issues. But I think if you look at the world of modern politics, there are also other risks, right? What the companies which are, technology owners, right? They may, get some restrictions, right? And you can see that now, not in, every region in the world, right? But if you think about folks in, China have been working a lot of saying, hey, we don't want to have U.S. government to have a kill switch to our technology, right? Or companies in Russia, right? And many other places in the region as well. But now, if you go to their history lesson, if you think about what somebody like AWS are going to tell you, saying, hey guys, we are looking to save you from Oracle clutches, right? Why don't you modernize your database, move to something like Amazon RDS Aurora, which will be more cost effective for you and it's more modern and otherwise better, right? But now let's see what history tells us in this regard. Now, anybody knows who is that young, good-looking gentleman right there? Larry Ellison, yes, and it's actually, the resolution here is not enough. It says like RSI for him on a T-shirt. That was like an early name of Oracle, right? And what did Oracle do when we were like a startup? Well, they were actually saving people from a vendor lock-in of the nasty big blue, also called IBM. Right? They say, hey, instead of you being locked in this kind of mainframes, right, hardware and software integrated, we just give you a database that you buy separately, and you can run it on a variety of a hardware, right, more cost effective, and so on and so forth, right? Now, let me ask you, how many do you think about Oracle as a company which saves their customer from vendor lock-in? No? No Oracle employees here? No? Okay. Now, how about that, maybe a statement about Oracle? Oracle doesn't have customers. Oracle has hostages. Yeah, that's probably appeals to more, right? Okay. Cool. So the other thing I would say when I speak about the lock-in, I think it's important to really understand why data is special. We often talk about this data concept of a data has gravity, right? And what does that principle means? One is data is heavy, right? If I simply have my stateless application, right, I can shut off my 100 instances on Amazon and spin them up on like a GCP in 15 minutes, right? If I have several petabytes of data stored in some particular format in some particular database in the cloud, it's quite a project to move it around, right? So data is heavy, data is sticky, right? And also what principle of gravity is, data kind of attracts applications, right? Because often, if I have my data in a particular cloud, I don't want the application to run in other clouds, often for cost, availability, and whatever other reasons, right? So you'll often place it in the same way, right? And I think that is why it's very important what data is that, if avoiding vendor lock-in is important, it's important for you then focusing on having your data not being locked in, I think is very important. Now, let's talk about what we have seen here and what trends which are kind of positive in terms of avoiding vendor lock-in we're seeing. One, of course, if some of you remember, let's say, early 2000s, right, on your development environment, you can say, hey, something like AWS, no, so it's not AWS, like Windows had this like a fantastic development platform, and if you are the open source guy, you are, writing the software with VI, or maybe Emacs if you are, I don't know, more enlightened or kind of whatever you want to call it, right? Or operating system. Anybody here has a like Solaris experience? Yeah. Well, I mean, when I remember again in the late 90s, early 2000s, Linux was a joke, right? It's wouldn't scale. I remember we even had this like a maximum file size was like a 2 gigabytes. Like people like say, what a joke of operating system it is. And then it's of course took a time. But how many of you are running Solaris now? Anyone? Well, I don't think that's a problem in this this country, but I have a friend who says, well, you know what? Actually, I do. I have this like a box in my basement. So when it becomes very cold, I can plug it in and I can run Solaris, and it's very usable and heating my house a little bit better. But I think what you have seen already in terms of that, like a general Linux space, we still have a lot of trends of that going on in the cloud as well. There is one way to approach things is, AWS, which again is kind of very nice and polished. But then you can also use a lot of cloud native solutions, which gives you much more vendor independence. And I think what that allows you is to give a cloud kind of its original intended role of being that commodity infrastructure. Because this is actually how cloud was sold to us, right? I mean, this is actually the slide I took from one of the early AWS presentation. And they were comparing cloud to electricity, right? But what is specific about electricity? It is extremely commoditized, right? I mean, I can take my laptop actually in even any country, plug it in the outlet, and it just works, right? But that also, of course, means what the margins are kind of providing electricity as not that big, right? And guys like Amazon don't want to be in a low margin business, right? So in our case, we can say, well, guys, we want you kind of to create more lock-in. It's not just going to be just commodity electricity, right? It's going to be integrated stuff, right? So now we'll make sure that if you want to plug in a different outlet, you'll need to, change your laptop, operating system, and whatever, and that's kind of inconvenient, right? But you can avoid that if you are running cloud native. And what does that mean those days? If you look at the foundation of a modern cloud native setup is their Kubernetes those days. The cool thing with Kubernetes is what that is ubiquitous, right? It can run, pretty much, anywhere, right? It can run on small devices, it can run on large devices. There are Kubernetes clusters with many, many thousands of nodes deployed in productions, right? There are, I understand, there have been even Kubernetes clusters flown into the space. When it comes to the databases, right, the important word to remember with Kubernetes is their operators, right? That is how a lot of database technology is deployed, right? At least deployed in production. The Kubernetes itself allows you to deploy even more simple ways. Like you can take a container, your database in container, boom, you deploy that node in Kubernetes and that works. It's simple, and that may work for the development, for testing, right, for playing it around. But the thing of database, which is kind of very interesting, is what a lot of databases are expected to operate many months, sometimes kind of many decades, and it needs to be kind of constantly up, not losing any data, losing kind of all your changes. Think about like a bank account, right? Like, hey, you know what? It's not okay to lose what there was, just, some transaction coming in your bank account, right? It's always have to be very, very, very consistent, right? So unlike if a lot of a stateless application, if something that you cannot just say, hey, you know what? I can tear it down and deploy a new version, right? You need to keep that data operated, right? And that is what we say what the database spend most of their time in day 2, where day 1 is deployment, right? Kind of from scratch. And day 2 is actually living with that kind of data, right, in production. That means you have to patch the database, scale it up, scale it down, deal with failures, right, and so on and so forth. And that is what operators do. While at the same time, that is where your simple container deployment of a database does not provide. Right. Now, you also may heard what Kubernetes has been built for stateless applications, right? Anybody heard that? And yes, that was initially the thing. But you know what, guys? The initial thing is not always how things get at being used. You know, some of you may know what Viagra was also designed as a heart medicine first, but that's not what it's the purpose it's found in the end. So things can change, and now Kubernetes is quite good at running stateful applications as well. Now, the thing with the operators as well, though, is what they offer quite different UX and require also a lot of Kubernetes experience, right? I've been yesterday on the talk by Chi, right here on the back, and she was saying, hey, this is how you deploy a database on Kubernetes. You can write this wonderful YAML file. It's just going to be 3 pages, and here you go, off to races. Well, that is very different compared to your database as a service experience, right, where I can do the same stuff, but not in the 3 pages, but in the 3 clicks. At the same time, the question is, can we use the Kubernetes operator as a foundation for our open source databases, right, to build on a Kubernetes? And the answer actually yes. If you look at a lot of modern database as a service solutions, right, and these are some of them which I know, they are built on the Kubernetes in the back. Because if you want to cover a bunch of clouds, if you want easy flexibility to add clouds which your customers are asking, then that is much easier way to do it compared to implementing that kind of with a native API with all the different clouds. Right? But this is, of course, all their stuff which is provided to you as yet another database as a service solution with yet another lock-in risks, right? But I think it doesn't have to be this way. And this is where you may want to take a look at their Open Everest project, which allows you to get this fantastic database service experience, simplicity without all this vendor lock-in, right? And we have Sergey and Chi out there in the back, right, who are from that project. If you want to learn more details, you can you can talk to them. Another thing which I think is very important when it comes to the databases to cover in an open source is their observability. And I would highlight another project in this case which can help. It is called Karoot, right? And I myself is going to be talking more about some of the things that Karoot does. But here I will mention only one thing. What is interesting if you look at in the cloud native space is a lot of people want to understand the environment more than solely database focused tool. And while we at Percona has amazing database focused tool called PMM, if you really want to go deep to understand what the hell is going on in that database, right? It's awesome. If you really want to understand the environment more holistically, what is happening in your Kubernetes cluster, events, maybe some networking issue, right, which impacts your application performance, right, in addition to database, right? That is something which Karoot is very good at. Okay, so that brings us to their summary. I think what we have their fantastic pace of innovation in a database space, right? And I think it's kind of was interesting how it's kind of sort of gets better and better, right? Because we had with all the cloud stuff, right? New models, a lot of investment coming in the space. And yes, many of that goes into commercial companies, which may then wanted to go and try to change a license. But, well, you cannot actually change the license, right? That is what we say it. But what that means is they are going to fork the project and have new changes coming with that new license. The old stuff it cannot be taken away, right? And a lot of those companies, they implement a lot of stuff, right, which is available for everyone before the license is being changed. I also think right now what is very interesting is we have even more acceleration happening because a lot of stuff can be at least kind of prototyped, explored with AI tools like Cloud Code, right? We have seen doing a lot of very interesting work with a databases, which makes that much more democratic, because databases, many of them are written in kind of hardcore C++. They're kind of out of reach for a lot of developers, saying, hey, if I want to try building PostgreSQL extension to do X, well, it's too hard, but maybe not if you work together with Fred Claude. Now let me finish up with a couple of public service announcements. One is we have our at Percona our premier series of events called Percona Live. These are kind of sort of larger conferences, and if open source databases are important for you, we have one event happening in May in United States, and then there will be another one coming in the fall in Europe. Another thing is what Percona actually turning 20 years old this year, right? And we built like some little website where you can see their Percona journey. If you have some story you want to tell, like, oh, I tried to run in Percona, but it actually destroyed my database, right, and set my computer on fire, please let us know, right? We are looking for some fun stories out there. And the last one is not really database at all related for this stuff. I have a little hobby of mine, if you will, which is about taking geeks and making them suffer in some mountains, or like maybe going beyond the polar circle, right, or something else, right? We are planning to go do some sailing with Alkin right there later this year. So if you guys interested in those kind of activities, please go ahead and join the flock, if you will. And if that's all I had to say, and thank you.